Alright, so now we're on our last gas law. This one's called Graham's law. Before we talk about the actual law, we have to talk about a few words. So diffusion is the tendency of molecules to move toward areas of lower concentration until the concentration is uniform. So say for instance, if we had a whole bunch of molecules over here, only a few over here, our molecules are going to move towards the area of lower concentration. They're going to do that until they're equal. And once they're equal, once they're equal, then they will move back and forth at the same rate. Now we need to talk about effusion. So effusion is when gases escape through a tiny hole in its container. So think about when you have a balloon and there's a little hole, it slowly releases gas. So the rate of effusion of gas is inversely proportional to the square root of the gas's molar mass. So Graham's law is rate A over rate B is equal to the square root of the molar mass of B over the molar mass of A. Make sure you're doing it flipped. So if rate A is on our top, our molar mass of B needs to be on top. If rate B is on the bottom, our molar mass of A needs to be on top. So let's try a practice problem with this. Calculate the ratio of the velocity of helium atoms to the velocity of neon atoms at the same temperature. So we said that our equation was rate A over rate B is equal to the molar mass of B over the molar mass of A. So we know how to find molar mass, so this shouldn't be bad. So our rate, so here it says calculate the rate of velocity of helium atoms, so helium is going to be our A to the velocity of neon atoms, so neon is going to be our B. Alright, so we can figure out our molar mass by looking at our periodic table. So first let's find the molar mass of neon, and that is 20.18 grams per mole for neon. And then for helium, we have 4.003 grams per mole for helium. Now we can just plug this into our calculator. We get an answer of 2.245. That's our answer there. Make sure you use the correct amount of significant figures, so each of these has 4, so our answer needs to have 4 significant figures.